Let's talk a little bit about data analysis techniques. And in particular, how to take a set of data and make some sense out of it. Maybe you have just like a set of numbers, just linear, one-dimensional set of numbers, and you think, there's no pattern to this. This is like maybe just random. But perhaps there could be a pattern to it. And I want to start finding out if there is or not. So what we're talking about here is a technique to look at that set of data differently. Maybe you've got a set of numbers. Maybe they're time intervals. Say it's a one-dimensional set of time intervals. And it's just looking pretty random, no pattern to it. Well, maybe you can represent that set a little differently and see if there's something there. So what we're going to talk about now is how to map. This is a great technique. This is a very interesting technique. Anybody can do this. How to map a one-dimensional set of data into two dimensions and get a little different look at it. Okay, and of course what I have in mind is my little dripping faucet project. I hear a faucet dripping, drip, 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 and maybe it's pretty regular, but if you turn the flow rate up just a little bit, it's no longer just drip, drip, drip. It goes drip, 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 or whatever. It's like something crazy's going on here. But is there a pattern to it? Well, I strongly think there is, and maybe a strange attractor. So, just looking at that string of numbers, which are the time intervals between drips, you really can't see anything. But here's a technique to look at it a little bit differently. So, we're going to map a one-dimensional set into two dimensions. And let's say, for instance, these are time intervals. Okay, I'm going to refocus the camera onto the writing board, and let's see if we can illustrate this concept. We've zoomed in a little bit so you can see the writing board behind me here. I just want to give a little bit of a plug to this great little book here. This is called Chaos by James Glick. And this is where I first heard about this technique. And this technique can be applied in many different ways. So if you don't have this book, get a copy of it. It's great. It's an easy read. You don't have to be a mathematician or a scientist or anything like that. It's an interesting and fun read. Okay, so what do we have here? We're going to illustrate this concept with a one-dimensional time series. So I've got this string of numbers, and it doesn't make much sense. 2, 1, 1.5, 2.5, 3, 2.5 again, 1.5. Well, what's up with that? Right? So I'm going to map this one-dimensional set of numbers, this string of numbers, into two dimension, and here's what I'm going to do. Here's what I'm going to use for that. I'm going to plot them in the XY plane. So here's X and Y. This is X, this is Y. I'm going to have 1, 2, 3, 4, which covers that set of numbers. And up here too, 1, 2, 3, 4. And so how are we going to map this string of numbers into two dimensions? Here's the key. Each XY coordinate is going to be like this. here's xy. And what we're going to have is tn plus 1. That's as simple as that. In other words, here's 1, 2, 3, 4, 5, 6, 7, and so forth, however many numbers you have there. So we're going to make up all these coordinates, and the first one would be T1 and T2, and then T2 and T3, and so forth. So the first point in the XY plane is going to be 2, 1. Then the next point will be 1, 1.5. Then the next point will be 1.5, 2.5, and so forth. So XY is going to be Tn and Tn plus 1. Let's give this a try and see how it works out. So we have this string of numbers here. Really doesn't seem to exhibit any kind of pattern. But of course, you know, I made these up so they would fit the example. But we're just talking about raw data here too. Take some raw data and look at it differently. See if it makes some sense. So let's try it and see what happens. First point is going to be 2, 1. Okay, here's 2, 1. And I know my scales are not perfect on this, but let's just give it a shot and see what happens. So 2, 1, and then we're going to have 1, 1.5. Well, here's 1, here's 1.5, and then 1.5, 2.5. Well, here's 1.5, here's 2.5, somewhere in there. 2.53 would be 2.53, 2.5 would be 3, 2.5, 2.5 and 1.5, 2.5, 1.5. So now, look what's happening here. We've got this set of coordinates in the XY plane, two-dimensional plane, and I don't need to draw this, but I will. It maybe looks something like this. So we've got some kind of pattern emerging, and we still need to figure out what that pattern is. It looks kind of like an oval that's offset and like that. But we've taken this string, one-dimensional time series, raised it up a dimension, plotted in 2 dimensions in the XY plane, and now all of a sudden a pattern is starting to emerge. A different way of looking at that set of data.